Hello modeling enthusiasts. Today I'll introduce you to GEOREKA geological modeling software, and we introduce a lot of new workflows. This video will contain a lot of new information for existing users as well, so I'll guide you through the new way of working. To do this we need to start GEOREKA, of course, so let's get going with that first. So as you'll see, when you start GEOREKA, it pops up with a dialog and the main application in the background. Here you see some past projects. 2 of them have been grayed out because I've deleted them while I was preparing for this recording. Let's recreate this one and I'll take you through all the steps you need to know. We'll start with creating a new project from here. We'll call this demo MRV because we'll use Marvin's MRV dataset for this. And we'll press save. Right, I'll make the window a bit bigger now as well, so you can see all the details. So once you start GEOREKA, you'll have your project on the left hand side, large 3D viewing area, and the buttons around it. What I'll do is I'll start working with some data, and as we go we'll explain what some of these buttons will do and then gradually go into more and more details. So first of all, the main thing that we need to focus on is the top left here, and in the middle there's an option to import data. So if you click on the little arrow down, you can select to import drill logs. Here we need to select 3 different files, and the first one is the color file as indicated here. So this is all importing directly from CSV files. We can select a different delimiter if we have other types of delimiters, and we want to enable the option if you have header in the file or not. Alright, so click next. This gives you a bit of an overview of what's in the file itself. So here you see the file itself with its headings, and you'll see the headings listed here on the left hand side as well. And for each of the headings we have to provide a number of types that GEOREKA will understand. For example, we need whole ID data, that's why it's already orange. We need X, Y, and Z, and these have automatically been assigned based on the names in the heading. If you want to change something, double click on it and you can choose a different one. So if you want to ignore this one, for example, set this to ignore and select a different heading that you think captures the type of data. Once you've set this one for the color files, we'll click next, and automatically we detected a survey file in the same folder, and this is selected here. If you have a different survey file, you just browse to it and then click next to do the same as before, so you get an overview of what's in the file itself with the different headings. And we need to specify, in this case, the whole ID, survey depth, and azimuth and dip. So the survey depth in drilling data typically is where the measurement was done. So your first measurement would typically be at 0 depth and then all the way down to the end of the drill hole. Click next. Here we can select various data files. So as an example, we have assays in lithology, and here these are captured in the geology file and the assay file. So we used control click like any normal multi-select option in Windows and click open. You see that the files are listed here now, and then we click next. First of all, we have the assay file. So for this one we have some numeric data, the copper and the gold, and we'll set this to values. Same for the gold, and we'll leave the other ones at ignore for now. Click next, and here we have our geology data, which is categorical data. So if we double click here, we select categories, and same for the zone, also categorical data, and click finish. As you see, the data is being desurveyed as imported, and after the desurveying is done, GEOREKA will detect if there's any errors in the data set. In this case, there were no errors detected because this is a nicely cleaned up data set. So we hit OK, and again for the second import, so we hit OK again. Now we have our data in a 3D view. Let's turn off the assays for now because we're not going to focus on that for now. And here on the left hand side you can see I have your rock type information and the zone attributes. Those are the two attributes that we've selected during the import. We want to change some of the things, so we can, for example, turn off the mix zone. See that it's, oh sorry, actually only turned on the mix zone. We can turn it around. So now we only have oxide layer and primary zone. And similarly, if we go to our rock type, we can select which units we want to look at. So in this case, we have a quartz porphyry running through here in the middle. Let's make that a bit more obvious, so we make it a bit orangey, and there we can see it quite clearly. That means that we want to change the granodiorite a little bit, so make it a bit more greenish. Okay, so now we can see that in the bottom right here. So this way we can quickly highlight and hide various categories in our data. And from here we'll actually dive straight into the modeling. We'll focus on the geology data for now, and what we'll do is start modeling this quartz porphyry fast with the granodiorite next to it, and then everything around it is AVT. So we'll start building this complete model. And in version 5.2, the way we can do this is by clicking here at the top. So if you hover over this button, it says that you can create implicit functions directly from drill hole data. If you do this, we can select our geology file here, and we'll actually focus on the rock type. Notice that there's this option to automatically create a model as well, and we'll leave that on because that's actually what we want to demonstrate. So we click OK, and the next dialog lists all the categories that it's found in the geology attribute data, and you see that we have the AVT, quartz porphyry, and the granodiorite here. First of all, there's some other options here as well. Automatically, when you want to build a model, it will default to creating a distance buffer around your data, so your model won't extend too far, and it can create a topography for you as well. If you don't have any topography data yet, then you can create one from your colors if you have drilling just from the surface. So we'll leave this turned on, and we'll focus on the units here. So as you can read, we should set up a chronological order of the units. In our case, we have the quartz porphyry as the youngest unit, the second youngest is the granodiorite, and finally we have our base unit, the AVT. What we'll do is actually move this downwards because the AVT is considered the oldest, and make it the bottom of the list. And then we have the option here to actually estimate this sort of anisotropy that we're expecting from the data. So the quartz porphyry, as we've just seen, is more or less planar. So we'll leave that as a planar anisotropy. Granodiorite is more or less intrusive, and AVT will set it to intrusive as well, although it's less important here because it's the base unit and it won't be modeled explicitly because it's just everything that remains after we've modeled the other two. If you have drilling data with lots more categories, by default all the categories providing less than 1% of the total length will be ignored, and so they will be turned off. So you can turn them on manually if you think that they're important, but other than that, the other ones will be ignored from processing. If you have certain units, like the granodiorite, for example, if you did not want to model this one, you could just ignore it here by unchecking the box in front of it. We'll want to have everything turned on, and we'll press OK. So what happens is that GEOREKA is automatically interpolating the different data sets that we've provided, so the quartz porphyry, the granodiorite, but also notice that we have a distance buffer and a unit above topography. These are now considered domains at this stage. So after creating the interpolations, and we'll show them in a minute, the different interpolations are added to our model setup. So this dialog says, okay, we want to create a model, we give it a model name, we want to have a base resolution, the type of output model, tetrahedra, or you want to have cubic blocks. You can select those options, And here you see that it's replicated the chronological order of the units that we identified. But notice that we did not specify the AVT, or, well, the AVT is not listed here as a separate unit. So we quickly show the details. See that all these domains, they have a label, but nothing on the outside of that domain except for the granodiorite. So once we get to model the granodiorite, everything that's left over will automatically be labeled AVT. Well, we'll come back to this in a minute again. So let's hide this for now, so we have everything set up, and we'll just go and build the model. This hides all the implicit functions, and now the model has been created, so this is very fast for this small data set. But here we now have our first model on our model folder. So if you click color settings, you can go and turn off the AVT, for example. So now you can see that we have the quartz porphyry and our granodiorite there. And we can see that compared to what we saw before, the granodiorite is actually sitting against the quartz porphyry. All right, so what actually happened just now? Let's go and have a look in our implicit functions folder. So let's just turn off the model for now. And here you can see that we have a number of implicit functions. So we have one for the topography, the distance buffer. We have to set it, but I'll leave that for now. But we can see the boundary here for the topography. We see quartz porphyry being interpolated and modeled this way. But as you'll also notice is that the quartz porphyry is not constrained to topography. And similarly, you can see that the granodiorite is actually intruding into the quartz porphyry itself. And that's where the modeling step comes in. So these are individual interpolation operations being done for each domain individually. And then in our modeling step, we are actually combining them. So if we right click on the model, we say edit model, you can see that we have this function here. So the quartz porphyry function is here, and it actually creates the QZP domain. So the domain label is set to QZP. Similarly, for the granodiorite function, it's listed here as the youngest domain, and the label that it has in the final output model is GND. So for each unit in our drilling data, we've created an interpolation and then added that interpolation into a model building step to produce our final output model. All right, so let's repeat this for the other attribute, because we don't just have the lithology information, we also have the weathering zones. So we have oxidation layer at the top, and we have a mixed zone in the middle. We turn on the mixed zone as well. So we have a mixed zone in the middle, and then there is a primary area around it. All right, so let's do the same steps. We actually want to create the implicit functions from our geology data set, but this time we select the zone as an attribute, but we also want to create the model as an output. So we press OK. Again, we can turn on the distance buffer, topography, it's all good. But here we have to set up the chronological order, or at least the approximated chronological order. So in this case, we have the oxide zone at the top, and move that all the way to the top. We have the mix zone, which is in the middle, and then the prime zone at the bottom. So the oxide zone is more or less planar, so we leave that with the planar anisotropy. And we have the mix zone, we'll set it as isotropic. And the primary zone, although we don't really have to specify it, because it's going to be the leftovers, we set it to isotropic just for convenience. Right, so now we hit OK, and you see again some interpolation, some implicit functions have been created and showing the outline. And these functions have been added to our modeling steps. So we automatically have a model name, automatically estimated base resolution output, and the order has all been added automatically as well. So we just press the build button, and you see we're in a few minutes here, or even a few seconds sometimes. you have a model. Let's start looking into this a bit more as well. So we turn off the oxide zone and we turn off the mix zone. You can see that we have a bit of an idea, and everything else is now assigned to primary zone. So if we turn this around, see that the primary zone is sitting underneath, and we have our zonal model as well. What you might have noticed is that our model has been clipped to these extents here. This is an important step to keep in mind, is that if you're using this option, it automatically uses the whole project extent for building any of the models. You can change that at the top here. There's an option to say, okay, adjust my extent, so you can actually change any of the directions, or you could just select the project extent, which is the default. I'll just save this just out of habit. I have my initial extent here, initial extent. I save this because if I add some more data into this project, for example, large topography, regional topography, or something else, the project extent is going to be a lot larger than just this area. So then it's good to have this sitting here, that I can use it for any of the modeling steps again. With these basics out of the way, we now might want to mix things up a little bit, because our model that we're looking to build, like this quartz porphyry zone, extending all the way to our topography now. But in many cases, we might not want to model this one into the oxide zone and just interested in everything below the oxide. But what we can do is actually right-click on our model here, and you see that you have the different options, and I'll go through each one of them in the later videos probably. But for now, we want to focus on the edit model. So here, bring up this dialog. This looks very similar to what we've done before, but at least here you see that you now have the options to change the younger and older units at this stage. But also notice that we have options to add or remove implicit functions into our model building stage. And that's what we'll do here. We've created our oxide function before, and I'll include it into this whole process here. But the oxide is sitting at the top. It should be the youngest before we do any of the quartz porphyry. So we start to move this up and say this is the younger unit. And then after the oxide is built, you'll notice that we have the quartz porphyry and the granodiorite sitting underneath. And this way we can update our model and select build model again. Now we should see the updated model here. Might be a little bit hard to see, but we see two different layers. So if I go here, I can turn this off and actually say update this one. Now you see that we have the oxide sitting at the top there, and then we have the AVT around it, and we have our quartz porphyry sitting underneath the oxide here, and granodiorite still sitting against the quartz porphyry. This way we can control what our output model looks like by integrating multiple different implicit functions and treating them as domain boundaries. And now you should have a bit of an idea of the basics for building models. As I demonstrated, we build a model by including multiple implicit functions as domains and constrain our models based on the relative age of each of the domains. So how do we control these implicit models a little bit? They are shown as triangulated surfaces here. So you actually have a bit of a preview of what a domain will look like. The color on the inside is shown where the domain has been specified. Let's switch this to rock type. So here we have the quartz porphyry, for example, sitting inside everything else. And the implicit function is the interpolation of these inside points compared to the outside points. It's not completely static, so you can actually export them out if you want to. But notice that if you change your model boundary, your model extent, apply this one, see that it's updating the implicit function and the way it's been represented to include this area above it now. So if we switch this back, this is the one that we wanted to use. This is why I like saving my extents, because I can apply this again and retain the same settings every time. It highlights a little bit how an implicit function works. So this is not a static object, but it divides space into like an inside and an outside region. And we can also see it here a little bit. If we change the cutoff, for example, you can see that it updates where the boundary is drawn, basically. In our type of modeling for categorical data, we typically divide the data that we want to model and say these are inside points compared to outside points. And that's why our cutoff for these ones is at 0, because that's the boundary between the inside and outside. But how we create this boundary depends a lot on various settings. And this is where we'll start this switch over to show you the workflow system behind GEOREKA's modeling. If I right click on my Topography, I can bring the option to show workflow. And you notice here that we're now switching to the workflows tab because it's such an essential part of GEOREKA. In the workflows tab, you have different groups of items available to you for doing all sorts of modeling, specific items for point clouds, for creating contours, for updating existing surfaces that you might have imported from somewhere else, smoothing them. But mainly, most of the items that you will be working with, especially the ones that are used in the workflows that I've just shown, are going to be listed in the volumetric modeling. The quartz porphyry that we've modeled is actually taking the geology data item from this here, put it into a workflow where it's converting data into indicators, and then from there it's doing the interpolation. In the background, GEOREKA has taken this data, so you click on the item in the tree that you want to model, and you click on the canvas again here. So say, okay, I want to have the data again. You can put it all here to actually set up your workflows. So I'll select and press delete to remove them again. In this case, GEOREKA has automatically set up these workflows for you. And the first step is that it's taking the data and it's converting some of that data into indicators. If we double click on this item here, it brings up a dialog with parameters. At the top here you see our main attribute, which is a rock type. That's the one that we've been using in our modeling, and the category that we wanted to model. In this case, we selected quartz porphyry. Because quartz porphyry is the youngest, you want to say, okay, what are the neighboring units that the boundary needs to create around the quartz porphyry. In this case, there's only granodiorite and AVT, and both are selected here. I won't go into all the details just now, but you can change these ones and see how they affect your model if you need to. An important one is up here. So by default, all the data is used when you're doing your interpolations. But if you set up your model extents, your model boundaries, you can actually select a subset of that data. By checking this box, only the data within your current extent is going to be used. And this is especially useful if you have very regional data and you'd like to focus on a particular area. You set up your model extent and then check this box to only use the data from that area. Hit OK. So what this step does is converting our segment data, so different segments in our drill set, and it's going to convert them into indicator points. Let me just demonstrate it now. I'll just rerun this one. So once you set up a workflow, you hit the run button at the top, and that will actually start to process this one. In this case, what has happened is that our output from this workflow is shown here in our 3D project view. And if we click on it, we can actually see that we have some settings here at the bottom, and we can bring that up. So I'll just make the size of the points a bit bigger so we can see them. And if we switch to our color tab, we have two attributes for the point data. In this case, we can switch between indicators, which is a bit more indicative of what's actually happening. As I mentioned before, our quartz porphyry here is considered the unit that we want to model, so it creates points on the inside, the red ones, giving them positive values, and then we have points outside, and they receive negative values. If you zoom in, what you see is that there's also green points just between them, and they are on the boundary between the inside and outside. We'll just focus on the actual workflow itself and how things work. All of our implicit modeling interpolates on point data. So here we've converted our segments into inside and outside points. By default, all the distance values are used. The distance is roughly giving an estimate of where things it is in relation to the boundary later on. But more importantly, you see that points outside of the boundary will be negative and points inside will be positive. That's where full workflow comes in. So we have our points converted from our input data, and then we have the interpolation function attached to it. So this is doing the implicit modeling. So here, once you double click on it, you have multiple parameters. One is to do the estimation of the anisotropy. Notice also here that you have the attribute to interpolate. So it could be indicator, but by default it's using distances. They tend to be a little bit smoother than indicators and generally perform a little bit better, but there might be circumstances where you want to switch to indicator. More importantly is this area here. Notice that we have different types of interpolation. By default, everything that we're doing in GEOREKA is actually using machine learning regression, but there's other options as well. So we have dual kriging, like ordinary kriging, but we use the dual variant, which makes it very similar to RBFs, and machine learning. Then you can select any of the covariance functions or variogram functions, depending on how you want to look at it. We support 3 at the moment: the exponential, inverse, multiquadratic, and spherical. By default, it's always using the exponential, and one of the most important parameters for this type of interpolation is the range setting. And these are all just estimated from the original data. What I want to focus on here is the anisotropy setting. Notice that by default, and that's what we selected at the start, is that we have a planar anisotropy estimate. What if we're not really happy with the shape of our porphyry? We can actually go back and say, okay, maybe let's try just isotropic interpolation and say, okay, let's rerun this workflow. And now you see that our quartz porphyry has been updated with an isotropic anisotropy. You see that some of the extents are missing. It's actually closing off a lot more quickly rather than extending outwards in the direction of continuity. Isotropic in general is probably not the best option to use, but we're also not quite happy with our planar anisotropy, although it did give a bit of an idea of what we want to have in the end. I'll set it back to estimate anisotropy here, hit OK, and we rerun this one to see the updated model. Notice this quartz porphyry here extending all the way out in both directions now. If we want to have more control over the anisotropy, we click on the second button at the top here. So this opens the anisotropy settings, and you notice that we have this ellipsoid sitting with our data, and I'll actually switch this to indicators so it makes it a little bit easier to see what we're trying to model. Our automatic estimation of the anisotropy actually did a pretty good job in finding the orientation, but maybe we are not quite as happy with the extent that it's been setting, so we could extend it a little bit more in that direction, for example. Yeah, that seems about right. Just one thing, the anisotropy ellipsoid or spheroid is generally in the middle of your project setting, so it doesn't really align to the data. It could be sitting on the side, on either way, depending on the distribution of your drill holes. That's okay because it's just using a global anisotropy anyway. So we're quite happy with the orientation, quite happy with the major axis now. Maybe we want to have it dipping downwards a little bit, or pitching a little bit. So we change the pitch a little bit so it's pointing down a little bit. Yep, that's fine. I'm quite happy with this. I'll try this. Now you notice that we have a label for the quartz porphyry function. So I'll override this one. Yes, please. You can check that our new anisotropy settings correct. Close this dialog, and we'll actually return to our workflows tab. Now I'll double click on my interpolation function here, but instead of using the estimate anisotropy, I'll turn this off, And here I select the anisotropy that I've just overwritten. You have different anisotropies for the different implicit functions that have been created, but here we want to have the new porphyry function anisotropy. We click OK and can go back to a free tab. Here in the bottom right is another run button. If I click it, it actually runs the workflow that's active on the workflows tab. So now this is actually updated our model with our new anisotropy. What we can do, if we have this open, we can now start making multiple changes and actually say, well, let's make this a bit eccentric, and we'll just make this very narrow. It's save, yes, close, and now we run this again. So now you see that you have a workflow and you can update it with your anisotropy settings. You could even keep this around while you're doing this. So if you say, well, that was a bit too much, I'll reduce this back, save this one, and rerun this workflow. I'll start to see my updates. I actually want to increase this one back again, and repeat this process. So this way, we can quickly play with our anisotropy settings, override it, and once we're happy, we just close this dialog. Similarly, for other units that we want to model, like the granodiorite, for example, we can change the anisotropy. We can do things so we can actually bring up the workflow for the granodiorite, change our settings here as well. Maybe we do want to have it estimated as a planar anisotropy, and we can run it and see what it looks like. In this case, didn't do a very good job at estimating it, but there's very little data for the quartz porphyry anyway. I'll just turn that on, hide the other units. There we go. So you can see there's no real directional information available anyway. So yeah, it's done a good job, but I think for this one we actually prefer to keep it isotropic. Rerun this one. Setting up the anisotropy for each and every unit is a very important step before you build your final models. So you go through, do each one of them, and once you're happy with all the different units, we'll check this one as well. It's a bit of a jump here, so it seems at least, but if you notice and start to look into it, there's actually no oxidation recorded in this last drill hole. That's why it tries to exclude this point here. That's why you start to see this curving up. We could actually ignore this drill hole if you wanted to. We'll leave that to another video. But now the main thing is to focus on the modeling steps and the anisotropy. And you should go through each and every interpolation to make sure that you're happy with the shape that it's produced. Adjust your settings and rerun it if you're not quite happy. Once you've done that, you can actually go and edit your model. We don't really need to edit anything here because our functions have been updated, so we just rebuild our model. And then we're gonna have a look, see what it looks like. Turn these ones, turn these ones off and see if they actually match our new function. Yes. So now you can see that the updated model actually honors the interpolation settings with the new anisotropy that we've applied to it. Before we go on to modeling numeric data, it might be a good time to actually explain a little bit if you have other types of data, like topography, for example, that you want to include in your model. I'll turn these off, and I'll turn this off for now. First, we need to import it, of course, and most data types that we import are actually listed in the second item here. If you click on the known file types, you can see that there's a whole range of different file types that can be imported. And in this case, we have some text data. It's really just a text file. We click on this to import it. We can filter the data. I'm not going to do that. And then this brings up the type of delimiter, and if it has headers because it's a text file. And similarly to the import of drill data, you see that you have headers at the top, X, Y, Z, and they're listed here again. And yeah, we just need X, Y, Z in this case. Optionally, you have some other things like values and categories that you can select here as well. But for now, this just stays at XYZ. Bring in all the data points. We can choose to skip and select every 5th or 10th point if we want to. I'll take all the points for now. Again, data shows up directly in our 3D view, and we would like to use this instead of our colors in our model that we created just before. First, what we need to do is also create an implicit function out of this. Right click on our point data, and there's an option to interpolate this as well. Again, we have options for how to do it in interpolation. Use the ML regression as a default. Estimated range, it's a bit large because the area is so big. I'll just drop that down to maybe 200 meters. And for this type of data, yes, these points actually constitute a boundary. The topography being the boundary of our model. Basically, click OK. And you can see that GEOREKA is processing in the background here. It's interpolating all the points. That's finished, and it's showing you the exact same preview. So notice that it's only creating the interpolated surface here where we have our model extended. The new data is extending all the way out, but we have our model extend still here, which is fine. That's only the region where we want to do the modeling. Now we have our topo large interpolation that we want to use in our model. So again, we can right click on our rock type model. We edit this model. And if we look here, there's this implicit function here that has the domain everything above topo. Alright, we're going to replace this one. So we remove this one and we're going to bring in this newly created one. Like topo large. Let's give it the same name above topo and hit OK. Now again, like before, we need to move this up because it's younger. And the oxidation layer sits on top of it. I'll just build the model now to illustrate what happens with if we don't do one of the settings. So I'll say build model. You can see that it's busy in the background building the model. Now we have our model here. And if we turn on our topography, you can see that the model hasn't really actually limited to what we've built before. As well, we have above topo sitting underneath. It's not really the way we wanted it to look like, right? I mean, this is not the way we intended it to. What we need to do is actually go back to edit our model, go to this one, either double click on the entry here or click edit domain after you selected it. So first of all, the above topo was actually below topo. So we need to change the polarity and say, okay, we actually modeled the wrong side. We hit OK, and let's build this one again just to see what it will look like now. Okay, looks a little bit better. Now, if you click on it, we have your above topo here, and then oxidation. Here we have the topography. But our model is actually not clipped by the topography as we had before. Of course, we can turn it off and say, okay, well, this is our model below the topography, and we can look at everything else, like side layer below. But what we actually want to do is remove everything below the topography. We right click on the model again, edit model. Now I'll double click on this unit and notice that we have this option here to actually remove part of the model. And this is actually removing the domain that we've specified. So the above topo will actually be removed from our final model. If I hit OK and now rebuild the model, I have to wait again for a little bit. But now you'll see that our model actually doesn't have a domain above topography. And it's actually clipped by the topography that we've just created. These two parameters, the polarity side and the option to actually remove a domain from your model, are really powerful ways of sort of sculpting the geological model the way you want it to. But there's one more to actually have a look at now. And if we go back to edit our model, I'll demonstrate that with the distance buffer. So if we zoom here, we'll look at the threshold. The distance buffer is set to 275 meters. That means that everything over 275 meters from the data is actually removed from the model. In this case, you hardly see it. So if I change this and make that 150 meters, hit OK. Now rebuild the model. This will actually use the implicit function, in this case a distance function, classify everything over 150 meters from the data as being distance to be removed from the model. So let's hit build model, see what it looks like. It's processing now. Let's wait for it a little bit. All right, now we see what the result is. Here you can see that our model has now been clipped by this distance buffer away from the data. So this way you can control a lot of what you actually want to model. If you want to change sides, positive to negative sides, so the polarity of the implicit function, the threshold of the implicit function, and to either keep the inside of an implicit function, which is the domain that you're trying to model, or actually remove it from the final output. Okay, so maybe now it's time to have a quick recap of what we've been doing. We started off mainly looking at our categorical data, our geology data, setting up implicit functions automatically by selecting the attribute and the data that we want to use and allow it to automatically create models. This in turn would create the various implicit models that we started using. And these implicit models were then combined into a model setting where we work from our youngest unit all the way to the oldest. And here we can combine various implicit functions that we've created to build our final output model. The output model is then shown like this, and we can display individual units by updating the views this way. And that basically covers all the essential bits of doing the modeling. Maybe quickly recap to actually show the details and think about the polarity and the threshold settings and the way you can actually edit the domain to change these settings. With this out of the way, it's time to start focusing on numeric modeling and then how we can integrate both.